Dark Ranger at Olympic National Park. He leads a team that hosts public telescope programs and full moon hikes at Hurricane Ridge Visitors Center in the summer. Last year, more than 1,600 people participated in their observing programs. John is an Astronomical League certified master observer and a member of the Olympic Astronomical Society in Bremerton, Washington. In the rainy season, he teaches physical science at North Kitsap High School in Poulsbo, Washington. Recently, he participated in the Astronomy in Chile Ambassadors Program, which is a collaboration between several of the largest astronomical organizations in the country. And the purpose is to train educators and amateur astronomers in all of the astronomical infrastructure that U.S. organizations are building down in Chile. And tonight he's going to give us an inside picture of those facilities. So please give a warm welcome to John Goar.
Thank you, woohoo. So I was selected in a competitive process to get to take really a dream trip down to Chile and get to visit something that your average person just doesn't get to see, the great astronomical observatories that the United States has built down in Chile. And in large part, the reason I was selected is because I do interact with the public so much. That's a shot of Hurricane Ridge, where for the last 9 years I've been doing outreach. And there we are with 3 telescopes looking at planets in the early evening. The telescope in the middle is the first telescope that I built. It's a 12.5-inch Dobsonian. And I'd like to thank Richard Berry for teaching me how to build that telescope. I bought his book. I couldn't have built the telescopes without his book. And that telescope has been used with 19,000 people since it was built in 2003. On the right is my 20-inch telescope. I call it Draco. And then Mike Reitmeyer is on the telescope on the left with a commercially made telescope. And so I really enjoy doing the outreach up at Hurricane Ridge. Let's see if I can make this work. Yeah, my presentation tonight is called Eyes on Chile, and I want to give credit to Tiffany Stone Wolbrecht, one of my cohort. She wrote this PowerPoint, and I stole it from her and just changed a couple of the slides around. So if you like it, the credit goes to her. We spent 10 days in Chile. We traveled around to 3 different airports and visited the great American facilities there, and I'd like to tell you that story. There I am in Chile, woohoo! So this is the Atacama Desert, and the reason I'm wearing a hoodie in a region that looks so hot is I was there in June, and that's winter for the southern hemisphere. And in addition, this is about 9,000 feet. Some of the driest areas of the world, which is one of the reasons that our telescopes are so successful there. I'd like to take a minute to introduce you to the cohort. These are an amazing group of people that I traveled with, and I learned really more from these people than I did from the scientists that I met and the administrators and visiting the facilities. Just a remarkable group of people. And so I'd like to tell you a little bit about my cohort. On the left is Dr. Stephen Case. He works at Olivet Nazarene University. He is into the history of science, and he recently released this book. It's a book about the history of Sir John Herschel. I recommended it. I was able to read it. It's called Making Stars Physical. And he teaches physics and astronomy. To his left is Kyle Jeter. He teaches high school at Marjorie Stoneman Douglas High School in Parkland, Florida. And he teaches all senior honors astronomy classes. I would kill to have that teaching assignment. Sadly, his school had a shooting that happened nearly a year ago. And he gave me this pin here that I'm wearing on my shirt just as a remembrance. It says, Douglas is strong on it. So he was able to tell us the story of the tragedy that he experienced there, and it was quite a story. To his side is Tiffany Stone Wolbrecht. She's the one that made this PowerPoint. She works at the Ward Beecher Planetarium in Youngstown, Ohio, and she's interested in using Kepler data to search for exoplanets. The lady wearing the Columbia shirt is a PhD student at Columbia University. That's Moya McKeer. And her research is into the stellar signatures, the spectral signatures of stars that are particularly close to us, searching for different populations, different origins of some of the different stars in our general neighborhood of the Milky Way. They embed a Chilean in every ASEP cohort. And next up is Yasmin Cacherio. She teaches at Concepcion School in Chilean, Chile, and she was really able to help us out a lot. Just a really interesting, warm lady, and she could speak Spanish. Dr. Nicole Zellner in the yellow is from Albion College, and she's really has a diverse interest in astronomy. She has gone to Antarctica with the NSF to search for asteroids. She's worked on space shuttle programs. She has analyzed lunar samples, and so she's highly regarded. But I really appreciated her too, because she is very interested in making sure that women are promoted in science, and so she's visiting these different astronomical facilities asking, well, how many women do research here? And what are you doing to improve that? And I appreciated that. Eileen Grzybowski teaches in Oklahoma, in Norman, Oklahoma, and I bonded with her because she and I are both botany majors, not really astronomy. But we were able to appreciate the flora of Chile, some of these things we've never seen. Sherry Lifson is the woman in the white hat, and she actually is a media specialist with AURA, the organization that manages these telescopes. And she really needed to see these telescopes because she's writing in social media about them all the time. And then there's me, and in the front is Sam Nagley. And Sam is a masterful astrophotographer. She is co-administrator of Telescope Addicts, and that serves about 30,000 subscribers. So just an incredibly diverse, we learn from each other a lot, and warm memories, warm friendships were made. So this is the ASEP symbol, and the first cohort went over in the year 2015, and I was in the 2018 cohort. There is applications being accepted right now for they've refunded it, and in 2019 a group is going to be going. And at the end of my presentation, I'd like to tell you about how maybe you could be the next ASEP ambassador. So why are we investing our money in Chile? That's really the question that I've come to share the answer to. Every year we are spending hundreds of millions of dollars over time. We're also spending an annual budget about in excess of $10 million to operate these facilities. Currently, 40% of the world's astronomy infrastructure is in Chile, and that's defined by a random decision of a 3-meter telescope or larger. But by the year 2022, with new telescopes coming online, that number is going to jump to 70%. And that just begs the question, why is it happening in Chile? A lot of it has to do with geography. And this is a shot of Chile from space. And labeled on the image is some of the facilities that we visited. And south is towards the top, and the Humboldt Current, a cold ocean current, comes up from Antarctica along the coast, and it has a couple of effects on Chile's weather. First of all, it makes a lot of fog out in the ocean, you can see that, but on the continent, it tends to make for clear skies. There are areas in northern Chile that experience 350 clear skies per year. The skies are all also very dry, and the air is very stable, and that is fortunate for the astronomers that work there. And then there's also the rain shadow effect from the Andes Mountains. They have control of their light pollution, and their government is highly motivated to work with other nations to have astronomers working in their country, and I'll explain a little bit more about that. So to compare Chile to the United States is a much larger nation, but if you put Chile sideways, it doesn't fit much up and down. It is just as long as the United States is wide. So this makes for some diverse climate at the north. You've got the Atacama Desert, arguably the driest place on the planet. In the center part of Chile, you have a climate closer to California. And wine grapes is a huge agricultural commodity there. They're very proud of their wines. And then if you go down into the south, you're going to see weather more like Alaska. Here's some glaciers coming into the ocean. So when we fly into Chile, we go to the capital, and we're going to visit some of the administrators that work in the capital. There are no major telescope facilities in Santiago because of the light pollution. About 7,000 people live in the capital city of Santiago, and it's a beautiful city. We visited the largest urban park in South America, and here is a beautiful statue for Mary. We took a sideways railroad car called a funicular to get up to the top of the hill where this was. And if you turn around and face the other way, there's the city, beautiful view. There's the next day. The clouds are starting to part, some fresh snow up in the Andes Mountains. And we're going to meet with some of the government officials of Chile. CONACYT, part of the Ministry of Education, oversees the cooperation with the United States, and also oversees the 10% of the telescope time that Chilean astronomers are afforded based on the deal made with the U.S. Organizations. And so we get to hear his presentation about how the telescopes in the country are helping their educational programs and bolster their scientific efforts, their research efforts. This graph, the blue one, shows the number of professors of astronomy in Chile over time, and it's grown from something like 25 up to about 100. They're calling this the Big Bang of astronomy in Chile. So we want to see some of the telescope facilities, so we have to get out of town. We travel north about 400 miles to the lovely coastal town of La Serena, and I suggest that you visit this place maybe next year because there's a total solar eclipse going through La Serena. When we're in La Serena, we're going to be going out into the countryside and visiting a school, and when we're there, it's Astronomy Day, and that's the reason that we were invited. So they have some solar telescopes, and they have a inflatable dome with a planetarium, and I get to listen to some lectures given to fifth graders in Spanish, and I'm not fluent in Spanish, but I did learn a new word. My favorite Spanish word is now infrarrojo. And looking around the playground, on one of the walls is the image on the left of Pablo Neruda. And Pablo Neruda is an incredibly well-known figure in Chile, a national hero. He's a Nobel laureate poet, and we see his figure everywhere we go. The Chilean people are just amazing. They're warm, they're very welcoming, and an illustration of that is we're taking our bus to go out to that school, and we pass a vineyard, and when we stop, the people that are picking the grapes pass grapes into the window of our bus, and they won't stop until everybody has this big bunch of grapes, and that's just the kind of people that we met the entire trip. So we're going to visit that evening a tourist astronomy facility called Alpha Aldea. There are literally hundreds of places that an amateur could go and get their hands on a telescope and view the nighttime sky. And so we were the host of Hugo and Maria Elena, and they're going to show us the universe through some of their telescopes. And that's what the sky is going to look like. One of the Magellanic Clouds on the left. The next day we go to Cerro Tololo. And Cerro Tololo at about 8,000 feet houses a number of different telescopes. And one group is called the Mushroom Farm. These are little 1-meter telescopes that are remotely controlled, most of them from the United States, perhaps belonging to different universities, so that a professor could open up a laptop at the University of Minnesota and operate one of these telescopes and collect data. This image shows some of the housing for the visiting astronomers. There's the dining commons up there. There's the newest telescope on the mountain. It had snowed a couple of days before, and they made a telescope, and by the time I got a chance to photograph it, it would melt it away. But the beautiful Andes Mountains in the background. The largest telescope there is the Blanco telescope. It's a 4-meter telescope, and it has a twin found on Kitt Peak. My understanding is that they can be linked together and used with interferometry. The telescope itself won the Nobel Prize in 2011 for some of its discoveries. And it has a deck cam, a new camera installed. And it's going to be doing a dark energy survey over 5 years, trying to determine exactly what is dark energy. This is as it's getting a little bit dark, and they open up the telescope, and yeah, that's what the skies look like there. La Serena is going to be about 90 miles away, so these are pristine skies. Both of the Magellanic Clouds. The sky glow you see is La Serena, but the photographer has managed to enhance it a lot brighter than it really did look. And if you haven't seen the Magellanic Clouds, you got to get down there. Perhaps you can find the the Southern Cross in this picture, along with Alpha and Beta Centaurus. They are kind of on the right near the top, the colorful cluster. Maybe you can see the cross in there. And then to the left, 2 bright stars are Beta and then Alpha Centauri. And both of the Magellanic Clouds. And this photo was taken by Sam Nagley, the wonderful astrophotographer that was with us. So if you look about 20 miles away and about 1,000 feet higher, here is Cerro Pachón, and that is the home of 3 major telescopes, SOAR, Gemini South, and under construction is the Large Synaptic Survey Telescope. And sadly, we were not able to visit these facilities due to snow. They weren't able to plow the roads. So what I'm going to show you about these 3 telescopes is images that we did not take. First of all, there's the SOAR telescope, and I believe this is a shot on the left of the primary mirror with the actuators of adaptive optics on the back. And you fire a laser up into the sky to create false stars to gather data on how the atmosphere is distorting the light. And with pushing on the mirror with these actuators, it will warp the mirror by millionths of an inch to correct for that in real time. Adaptive optics has really gotten a lot better data out of these telescopes. And the US military requires them to be shut down if certain spy satellites are flying overhead, or they're also watching for commercial aircraft. They don't want to hit those with the sodium laser. To see how effective the adaptive optics are, there's an image of the sky, and the inset shows 3 different versions. What you would get on the bottom without adaptive optics, with the first generation of adaptive optics, and with the newest system. And you can see how much cleaner the data is when you correct for the distortion of our atmosphere. So there you're looking at the primary mirror of the Gemini South. It is an 8-meter telescope. It has a twin in Hawaii called the Gemini North. And they also can combine their images and work with interferometry. So now we're going to hop a plane and go 400 miles farther to the north to the Atacama Desert. And this was probably the favorite part of the trip for me. We're going to stay in San Pedro de Atacama, and it's very remote. There's not another town around it for about 100 miles. It is a touristy town, and really enjoy being there for a few days. Lots of dogs running the street. Some volcanoes in the background. Every once in a while, one of those volcanoes would vent a little steam, and we Americans would become a little nervous, but the locals say, yeah, that always happens. We saw some wildlife when we were there. This is an animal called a vicuña, a smaller relative of the alpaca, and their wool is highly prized, and we luckily got to see one. The car could not stop for us to take better photos. And we're in the Atacama Desert to visit ALMA, the Atacama Large Millimeter Submillimeter Array. It's a telescope built out of 66 radio telescope dishes. The largest of them, 50 of them, are 12 meters in diameter. And it's located at an altitude of 16,500 feet to get above a lot of the moisture that would distort the radio image that we would get. And these telescopes, when we visited them, were in a safe mode because there had been a storm a couple of days before. So they're all pointing down, and they're all going to have to be checked out by technicians before they're used again. The scientists and the crews that maintain them spend most of their time down about 9,000 feet at a control center, and that's where this photograph is taken. And at this altitude and with this dry of sky, ultraviolet radiation is a real problem. So they have this sign up here saying how much ultraviolet there is. And they have bajo, medio, alto, all the way up to extremo. And the day we were there, it was extremo. You walk through the building, and everywhere you go, you can grab some sunscreen from dispensers on the walls. So you're going to want to lather up with that sunscreen every few hours. The array site is at 16,000 feet, and we took supplemental oxygen with us. We were also checked out by a physician to make sure that we were healthy enough to be at that kind of altitude. One of our cohort was denied being able to visit the high site. The ALMA does a huge diversity of research. It's amazing the different kinds of things that can be studied with radio waves. This is HL Tauri. It is a protostar developing, and here we're getting evidence of planetary formation. The dark regions that we see in this image represent where something is removed material from the surrounding gas around this protostar. The telescopes are moved around and put in different arrays depending on what you want to study.